तो नमस्कार, आदाब, सत श्री अकाल, कसकाए, केम छो, hello and welcome in GATE Wallah. This is your next lecture of the subject vibration. So today we'll start most important topic which is very important for aerospace engineering, that is natural vibration of 2 degree of freedom system. Okay, because na just one second. And welcome in GATE Wallah. This is next lecture. Because na in this topic student faces lot of difficulty. Okay, generally from this topic questions comes for the calculation of natural frequency. So a student face difficulty in solving the problem of natural vibration of 2 degree of freedom system. So that's why this is very important, na? So I'm starting without any delay. Okay, so which topic we are going to cover today? First we'll discuss the introduction of 2 degree of freedom vibration. Then we'll discuss how to calculate natural frequencies of 2 degree of freedom system. Then one more important concept we will discuss here, the concept of mode shift. After that we'll discuss how to write displacement equation in 2 degree of freedom system. So discussing one by one. See, first of all, what is 2 degree of freedom system? Okay, or what is the meaning when I'm saying vibration of 2 degree of freedom system? So see, if you see this diagram, na, I'm making one more diagram to explain this concept. Okay. If you see this diagram, na, this is general spring mass system. One spring is directly attached to the point mass right now. Okay. Now, mass is, during vibration, mass is moving in this direction. So, what will happen now? In this diagram, suppose the displacement of this mass from its mean position, I am referring as x. So, here, if you know the value of x now, then you can give all the information related to displacement. Like right now, this spring is directly attached to the mass. So can I say if this mass is displacing from a mean position by x distance, displacement of this spring from mean position is also x. So can I say with one information related to motion, I am able to describe the motion of entire system. Means the degree of freedom of this system is 1. So it is single degree of freedom vibratory system, which we already covered in chapter 1. Okay. But you will see this diagram. Here, suppose this is mass 1. Suppose the displacement during vibration, displacement of this mass 1 from mean position I am referring as x1. Similarly, displacement of mass 2 from mean position I am referring as x2. So here, if you know only the value of x1 now, then you cannot describe the motion of entire system. Why? See, this spring is between fixed and mass 1. So if displacement, right now suppose I know the value of x1 only. So if you know the value of x1, you can tell the displacement of this spring, it is also x1. Okay. Yes. But what about displacement of this spring? Because it will depend upon x2 only also. Okay. Similarly, what about displacement of this spring? Because displacement of this spring will be equal to x2, but right now x2 is not known. So can I say in this diagram, only with this one information, I am not able to describe the motion of entire system. But what will happen when along with x1 we know the value of x2 also? Now you will be able to describe the motion of entire system. How? Now see, if I know x1 and x2 both. So this spring is between fixed and mass 1. So displacement of this spring will be x1. Similarly, this spring is between mass 2 and fixed. And displacement of mass 2 is x2. So can I say displacement of this spring is also x2? Now, what about displacement of this spring? So, it is between m1 and m2 and displacement of mass 1 is x1, displacement of mass 2 is x2. So, can I say if x2 is more, then displacement of this spring will be x2 minus x1. If x1 is more, then displacement of this spring will be x1 minus x2. Now, whether it is x1 minus x2, whether it is x2 minus x1, let's assume x2 is more, then it will be x2 minus x1. Okay, but whether x1 is more or x2 is more, but if you know the value of both x1 and x2, you can tell the displacement of this spring also. Means in this vibratory system, I require at least 2 information related to displacement to describe the displacement of entire system. And since here we require 2 information, that's why the degree of freedom of this system is 2. Okay. Okay. And in this chapter, we are going to discuss the natural vibration of 2 degree of freedom vibratory system. Okay. Yes. So this is first part. Now here, when we are discussing single degree of freedom system, then first we were deriving the governing equation, or you can say differential equation of vibration. Similarly, here also, first we will derive the governing equation. Okay. And when you will derive the governing equation, after that we'll understand one more concept in 2 degree of freedom vibrating system, that is the concept of coupling, whether it is static coupling or dynamic coupling, or both it is having no static coupling, no dynamic coupling, or only static coupling, only dynamic coupling, or both static and dynamic coupling. But for that, first we'll derive the governing equation of vibration here. Okay, now see, to derive governing equation, since its degree of freedom is 2, so consider the displacement of this mass from mean position is x1 and displacement of this mass from mean position is x2. Okay, it is your will. If you want, you can take both x1, x2 this side also. I am taking this side. Now, if actual displacement this side, automatically x1 will come positive. If it is this side, it will come negative. Very simple. And x2, displacement of this mass from mean position is x2. Okay, now what I am doing, I am drawing the FBD of mass 1 separately and FBD of mass 2 separately. Okay, so you can see with the mass 1, this is spring 1. Suppose this is spring 1, spring 2, and spring 3. So spring 1 and 2 are attached. So if you are drawing to FBD of mass 1, we need to cut this spring 1 from this location, and we need to cut this spring from this location. Similarly, if you are drawing the FBD of mass 2, we need to cut this spring 2 from this location, and this is spring 3 from this location. Okay. Okay, you need not to be hurry. Okay, suppose here I am drawing. So this is mass 1, displacement of mass 1 from mean position is x1. With this is spring 1 it attached, which I cutted from this location. At the location from where we have cutted the spring, at that location internal force will come, Yes. And right now the stiffness of this spring is K1, I am writing here. Now with this is spring 2 is attached, which I am cutting from this location, and stiffness of this spring is K2. Here I am drawing the FBD of mass 2. With mass 2, this is spring 2 and 3 are attached. I am cutting spring 2 from this location. The stiffness of spring 2 is K2. This is spring 3, which I am cutting from this location. And the stiffness of spring 3 is K3. Okay. Now displacement of mass 2 from mean position is x2. Okay. Now, see, first we apply restoring force, and since it is a spring mass system, because spring are directly connected to the mass, here restoration will only occur due to the stiffness of spring. So here when we will consider restoring force, we will consider spring force due to the displacement of spring from mean position. Now here do calculation carefully, First of all, spring force. Okay, so at this location spring force of spring 1 will come, Now see, the stiffness of this spring is K1. Now see, what is the displacement of this spring from mean position? So right now this spring is between fixed and M1. So can I say displacement of this spring will be the same as the displacement of mass 1 because it is fixed, and displacement of mass 1 is from mean position is x1. So can I say displacement of spring 1 from mean position is also x1? But by this amount, spring will elongate or contract. It is very important, because if spring will elongate, the nature of force will be tensile. If it is contract, its nature will be compressive. So see, if x1 is, mass 1 is going in this direction by x1, can I say this spring 1 will elongate? So by this amount, spring 1 is elongating. Okay. So can I say spring force in the FBD of spring 1 will be K1 x1, and its nature is tensile. Okay, tensile. See, if now x1 is in this direction now, okay, so automatically x1 will come negative, and x1 is coming negative, so automatically spring force of spring 1 will come negative. Negative means actual direction will be the opposite what I had taken during derivation. But right now, as per this direction, spring force of spring 1 is K1 x1, nature is tensile. Now here in FBD of mass 1, here we are drawing the spring force of spring 1. So first draw the direction, correct direction. Its nature is tensile. So at this point, draw such arrow which will try to elongate this portion of spring. Now to elongate this portion of spring, we need to draw arrow like this. Okay. Now the value is K1 x1. Very easy. Yes. Now here from this location we have cutted the spring 2. So to draw spring force here, we need to find what is the spring force of spring 2. Now it is very important. Now you can see spring 2 is between x1 and x2. So can I say if x2 is more, the displacement of spring 2 will be x2 minus x1. But in that case, this x2 motion is dominating because x2 is more. So, and if due to x2 motion, if you try to imagine now, this spring will elongate, and due to this motion, this spring will contract. So if x2 is more, this is dominating. So can I say net displacement of this spring will be x2 minus x1, and its nature is tensile. But if x1 is more, then net displacement of this spring will be x1 minus x2. But in that case, its nature will be compressive. Okay. But right now we are doing the derivation. So right now I don't know whether x1 is more, x2 is more. So when you are deriving the governing equation, you can assume anything. It is your will. If you want, it is just an assumption. Do for derivation. If you want to assume x2 is greater than x1, you can assume. If you want to assume x1 is greater than x2, you can assume. It is your will. Okay, like if we are assuming x2 is greater than x1, then I will say right now net displacement of this spring is x2 minus x1, and here x2 is dominating. So by this amount, spring 2 will elongate, because this motion it is elongating. Okay, but see, I am doing derivation by assuming x2 greater than x1. But whatever final expression will come after derivation, it will be valid for all combination of x. Whether x2 is greater than x1, whether x2 is less than x1. Reason, because if I am drawing the force as per this direction. Now, suppose actually x2 is greater than x1. So, automatically x2 minus x1 will come positive. But if actually x2 is less than x1, then automatically this will come negative, na? And negative means right now we have assumed elongating. So, if it is coming negative means it will be contract. It will contract. So, it is your will during derivation whether you want to assume x2 greater than x1 or x1 greater than x2. But whatever final governing equation will come now, that will be valid for all combination of x. Okay, that valid is valid. This assumption I am taking just for derivation. But actually whatever final equation will come, it is valid for all combination of x. If you will assume x1 greater than x2 now, then also if you want, you can check in your home, final expression will be same. Because when you will assume x1 greater than x2, now I will take displacement this spring as x1 minus x2. But then I will take nature compressive, not elongating. Okay, so automatically sign part will get covered. Okay, I will prove also, don't worry. But right now I am doing derivation by assuming x2 is greater than x1. And if you are assuming x2 is greater than x1, okay, but whatever final equation will come, that will be valid for all combination of x. So displacement of this spring will be x2 minus x1, and by this amount it will elongate. So can I say spring force of this spring will be K2 in bracket x2 minus x1, and its nature will be tensile. Okay. Now here we have cutted the spring 2 from this location, and we know spring force of this spring right now as per this notation is tensile. So at this point draw such arrow which will try to elongate this portion. For that I need to draw arrow like this. Now the value of force, it is K2 in bracket x2 minus x1. Okay, this is also spring 2 which is in a body of mass 2. So here also spring force of spring 2 will come. But how will draw? First draw that arrow. Draw such arrow which will try to elongate this portion of the spring, because it is tensile, na? So now to elongate this portion we need to draw arrow like this. Okay, and you already know, na, whenever we are drawing FBT, whatever arrow is coming here, equal and opposite will come here. Okay, but that will automatically come. It's tensile, so draw such arrow which will try to elongate this portion. Now the value K2 in bracket x2 minus x1. Now this is spring 3 which I cutted from this location. So what is the spring force of spring 3? So stiffness of spring 3 is K2. Now its displacement, you can see it is between x2 and fixed. So can I say what the displacement this spring will be equal to x2 because it is fixed. Now direction of x2 is like this, and as per this direction, can I say it will contract? Because it is contracting spring 3, na? So right now, can I say the displacement of spring 3 is x2, and by this amount it is contracting. Okay. So spring force of spring force will be K3 x2, stiffness K3, displacement x2, and it is contracting, so its nature will be compressive. So first draw the direction here. Since it is compressing, so at this point draw such arrow which will try to compress this portion. For that I need to draw arrow like this. Now the value will be K3 x2. That's it. So we have applied all the spring force. But here if you want to use the equation of equilibrium, now I need to apply inertia force. So first of all, inertia force in the body of mass 1. So the mass of mass 1 is m1. Now its displacement from mean position is x1, because displacement of mass is 1 is x1, na? So it, can I say its acceleration will be x1 double dot, velocity x1 dot, acceleration x1 double dot. And since we are calculating x1 double dot by differentiation, its direction will be same as x1. Now if acceleration is x1 double dot, inertia force will be mass which is m1 into acceleration which is x1 double dot. And its direction will be opposite to x1 double dot. Right now x1 double dot is this side, So can I say inertia force will be in this direction? Similarly, inertia force in FBD of mass 2. So mass to mass is m2, its displacement is x2, so acceleration will be x2 double dot. Since we are calculating by differentiation, its direction will be same as x2. So now inertia force. So mass of this mass is m2, acceleration is x2 double dot. Direction, it will be opposite to x2 double dot. Right now x2 double dot is this side, so inertia force will be in this side. Okay. Now after applying inertia force, we can consider that individual FBD are in equilibrium. So what we'll do now, in the FBD of mass 1, since all forces are coming in x direction, so what I am using in FBD of mass m1, use this equation, summation of force in x direction equal to 0. Now while using this equation, suppose I am adding this side force and subtracting this side. It is your will. If you want to add this side, then subtract this side. But most of the force are coming this side. That's why I am adding this side force and subtracting this side. So right now m1 x1 double dot is this side which I am adding. So it will be plus m1 x1 double dot. K1 x1 is also this side which I am adding. So it will be plus K1 x1. Now K2 in bracket x2 minus x1 is this side which I am subtracting. So it will be minus K2 in bracket x2 minus x1. No other force are coming. So equate with 0. So this is the first equation which we got, governing equation which we got from the FBD of mass 1. Just I am setting this in standard form. Like what I am doing now, I am writing x1 double dot term first. Then if x2 double dot is coming, then I will write that term. Similarly in displacement, I will write x1 term first. If x2 term is coming, so then I will write x2 term later. In sequence I am writing. Like here x1 double dot is coming, write this. Okay. Now x2 double, no x2 double dot term is coming. Now see x1 term. So it is plus K1 x1. First I am expanding, minus K2 x2. Now minus minus plus K2 x1 equal to 0. So okay, m1 x1 double dot, K1 x1 plus K2 x1. So x1 you can take common. So it will be K1 plus K2 into x1. Now x2 term, this is minus K2 x2 equal to, suppose this is equation 1. So this is first governing equation which we got from the FBD of mass 1. Clear? Yes. Similarly, now here I am discussing interesting what I was saying earlier, that we had done the derivation by this assumption, but whatever final equation is coming now, it is valid for all combination of x. Reason na, even instead of this, if we assume x1 greater than x2 now, don't write this, just for understanding and explaining, you will get same equation. Why sir? Because if you will assume x1 greater than x2, then displacement of this spring, I will rub this thing just for understanding and explaining, x1 minus x2, but by this amount it will contract. So here compressive force will come and it will be K2 in bracket x1 minus x2. Okay. So this force is coming this side, which I am adding. So it will be plus K2 in bracket. So here instead of this, plus K2 in bracket x1 minus x2 will come. But you can see both are same. Because if we bring minus inside, it will become plus, and if we bring minus inside, it will become x1 minus x2. So ultimately both are same. That's why I was saying, by taking this assumption, whatever final equation is coming now, that is valid for all combination of x. Okay. Similarly, to find second governing equation, here since it is 2 degree of freedom system, you will get 2 independent governing equation. So to find second governing equation, what we'll do, in the FBD of mass m2, use summation of force in x direction equal to 0. Okay. Now while using this, again I am adding this side force and subtracting this side. So m2 x2 double dot is this side which I am adding. So plus m2 x2 double dot. K2 in bracket x2 minus x1 is this side which I am adding. So plus K2 in bracket x2 minus x1. Now K3 x2 is this side which I am adding. So it is plus K3 x2. This is equal to 0. So it is m2 x2 double dot plus K2 x2 minus K2 x1 plus K3 x2 equal to 0. Now again to write in standard form, first I am writing x1 double dot term, it is coming, then x2 double dot term, then in displacement first I will write x1 term, then x2 term. So no x1 double dot term is coming, now x2 double dot, yes this term is coming, so it is plus m2 x2 double dot term. Now see x1 term, so this x1 term is coming which is minus K2 x1. then x2 term. So it is plus k2 x2 plus k3 x2. So if I will take x2 common, it will be k2 plus k3 into x2. Yes, so this is second governing equation. Clear? Yes. Now for natural frequency calculation, if you derive these two equations, you can easily calculate. But sometime now I am writing these two equations in separate slide. First equation which we got from FBD of mass 1 is m1 x1 double dot plus k1 plus k2 into x1 minus k2 x2 equal to 0. So this I was referring as equation 1. Now the second governing equation which we got from FBD of mass 2 is m2 x2 double dot minus k2 x1 plus k2 plus k3 x2 equal to 0. Okay. Now we can write this terms now in this equation in a matrix form. So what is the benefit in writing in matrix form now? In one matrix form, in one governing equation which you are writing in matrix form, you can represent both the equation. But if you are writing in matrix form, how we can write? So see, for single degree of freedom system now, for natural vibration, we were getting equation like this: mx double dot plus kx equal to 0 na. So now what will happen now? Now this, instead of this m, mass matrix will come. Okay, and instead of this stiffness, stiffness matrix will come. Okay, so how we can write now? See, mass matrix into acceleration plus stiffness matrix into displacement equal to 0 means 0 matrix. Okay, now see now, in acceleration, ultimately two acceleration component is coming now, x1 double dot and x2 double dot. So see, this acceleration term will be now, if you are writing in the matrix, it will be of order, sorry, 2 by 1, means 2 row, 1 column. Similarly, in this displacement also we will get 2 by 1 matrix. How? So see, one acceleration term is x1 double dot, another is x2 double dot, which is the acceleration of mass 2. Similarly, in displacement of mass 1 is x1, displacement of mass 2 is x2. Okay. Yes. Okay. Now, how will write this mass matrix? So see, in this mass matrix now, this first of all, element which are coming in first row, that is decided by this first governing equation. Similarly, the element which are coming in second row, that is decided by second governing equation. Same thing is here. In that stiffness matrix also, the element which are coming in first row is decided by first governing equation. The element which are coming in second row is decided by second governing equation. Now, how we can write? So, in first row, two element is coming because two acceleration term are there, na? x1 double dot, x2 double dot. So this first element is representing the coefficient of x1 double dot in equation 1. Similarly, this second element is representing the coefficient of x2 double dot from equation 1. Okay, like see, you can see right now in equation 1 the coefficient of x1 double dot is m1, so this element is m1. Similarly, in equation 1, x2 double dot double term is not coming. So, can I say this is 0? Because coefficient of x2 double dot in equation 1 is 0. Similarly, the element in second row is decided by second equation. So, again, same concept. This will represent the coefficient of x1 double dot in equation 2. And this will represent the coefficient of x2 double dot in equation 2. So right now the coefficient of x1 double dot in equation 2. So in equation 2 x2 double dot, sorry, x1 double dot is not, term is not coming. So it is 0. Now in equation 2 coefficient of x2 double dot is m2. So it is m2. Okay. Now why I am writing like this, you will understand. So ultimately now this mass matrix will always be of 2 by 2 order. Same thing, stiffness matrix is also 2 by 2 order. How you can write this? So see. Again, element in first row will be decided by equation 1. So this element will represent the coefficient of x1 in equation 1 and this is coefficient of x2 in equation 1. Now, coefficient of x1 in equation 1 is k1 plus k2. So this is k1 plus k2. And coefficient of x2 in equation 1 is minus k2. So this is minus k2. Now, same, the element in last row will be decided by equation 2. So, say this first element will represent the coefficient of x1 in equation 2. Now, coefficient of x1 in equation 2 is minus k2, so it is minus k2. Now, it will represent the coefficient of x2 in equation 2, and coefficient of x2 in equation 2 is k2 plus k3. Okay. Now, if you are writing in this form, now, sometime examiner will give directly the governing equation in matrix form. Means ultimately both of this equation is given because he will expand this. Expand this means first row, first column. So it will be m1 x1 double dot plus 0 x2 double dot. So ultimately this term is coming plus k1 plus k2 x1, this term, minus k2 x2, this term, equal to 0. Similarly, second equation, second row, first column, 0 x1 double dot, m2 x2 double dot, minus k2 x1 plus k2 plus k3 x2 equal to 0. So this is governing equation in matrix form. Sometime examiner asks. Now, what is the meaning of static and dynamic coupling? So see, understood how, since it is 2 degree of freedom system now, so how displacement of mass 1 and 2 are linked with each other. Okay. So see, that are linked with this non-diagonal term in this mass and stiffness matrix. Because see, this is representing the coefficient of x1 double dot in equation 1, okay, which we got from the FBD of mass 1. So see, x1 and x1 double dot is displacement and acceleration of mass 1. So see, if in equation 1, in first row, this is directly linked with x1 double dot, but it is linked with x2 double dot, which is the acceleration of other mass. Okay, so this non-diagonal term is related to the displacement of other mass. Like see, this is are the coefficient which we got from the equation 2, and displacement of mass 2 is x2. So it is directly linked with x2 double dot, but it is linked with x1 double dot, which is the acceleration of other mass, na? Because this equation we got from the FBD of mass 2, whose displacement and acceleration are x2 and x2 double dot. So here other mass displacement is x1 double dot, and with x1 double dot this term is linked. Okay, same is here. This non-diagonal term is representing the relation, like see, it is representing the how we are relating mass 1 from other mass, from the displacement of other mass. Okay, so see, if in mass matrix non-diagonal term are non-zero, right now it is 0, but I am first discussing, it means the system is having dynamic coupling, because inertia force is nothing but a dynamic force. Okay, if this non-diagonal term are 0 in mass matrix, then we say there is no dynamic coupling. Okay, similarly because static in stiffness matrix, if non-diagonal term are non-zero, means it is having static coupling. Okay, and if this non-diagonal term are 0, means it is having no static coupling. So sometimes examiners say in the vibratory system shown in figure, it is having static coupling, dynamic coupling, no static coupling, no dynamic coupling. So just write this in matrix form. Yes, you can see here the non-diagonal term are 0, means it is having no dynamic coupling. First answer. Here non-diagonal term are non-zero, means it is having static coupling. So what I am trying to say, in first I am writing this mass matrix, if non-diagonal term non-zero, means it is having dynamic coupling. Since it is cross curve, so I am not going in too much detail, na? Okay. If it is 0, it is having no dynamic coupling. Okay. Similarly, if in stiffness matrix non-diagonal term is non-zero, means it is having static coupling. If it is 0, means no static coupling. In GATE Express, this type of question has already come. Okay, and if this question is coming, same question, mostly in 2 degree of freedom, this type of question will come. So I have proved. Right now in mass matrix non-diagonal term is 0, means it is having no for this question, this conclusion I am writing, it is having no dynamic coupling, and since stiffness matrix non-diagonal term is non-zero, means it is having static coupling. 1 mark question can come na. Yes, coupling here, see, coupling means how the displacement of mass 1 and mass 2 are linked with each other. Okay, see what I am trying to say. This equation 1 we got from the FBD of mass 1. Yes or no, Akash? This equation 1 I got from the FBD of mass 1, and displacement of mass 1 is x1 and x1 double dot. Displacement and acceleration of mass 1 is x1 and x1 double dot. Okay, but here x2 term is also coming, which is the displacement of other mass. Displacement of other mass. So the in equation 1, now through this also you can understand, in equation 1, the displacement or acceleration of other mass is coming or not, displacement of other mass is coming. And with that term, stiffness is multiplied or mass is multiplied. So with this term, stiffness is multiplied. Means it is having static coupling. Static coupling means through stiffness, the displacement of mass 1 is related with displacement of mass 2. But it is having no dynamic coupling, because here M2 with X2 double dot, M2 is not coming. Like suppose in this equation, this term is also coming, plus M2 X2 double dot or minus, means it is having dynamic coupling also. Similarly, if you see the equation 2, equation 2 we got from the FBD of mass 2, whose displacement and acceleration is x2 x2 double dot. That term is coming good. But here, if this we got from FBD of mass 2, whose displacement and acceleration are x2 x2 double dot. So here x1 term is also coming, which is the displacement of other mass. And in displacement of other mass, stiffness is coming, means again it is having static coupling. Okay. Now, the most important discussion in 2 degree of freedom natural vibration is the calculation of natural frequency. Generally, question will come from this part. Okay. First, I am discussing the steps na. When I am discussing calculation of natural frequency na, okay, don't try to understand everything at the same time, because you will get confused. Okay, this discussion required at least 1 hour discussion. So first listen the entire 1 hour discussion, then ask any doubt. Okay, because now during discussion I will take various assumptions, but those will be clear when I will complete this topic. Well, I will complete. So don't be in hurry, because it is time consuming to understand this topic. But once you will understand now, you will be able to solve all problem regarding natural frequency calculation for 2 degree of freedom system. So don't be in hurry na. See, for this question, displacement of mass 1 from mean position is x1, displacement of mass 2 from mean position is x2. After that, we have already derived the governing equation. This governing equation I am writing here. See, it from FBD of mass 1 we got m1 x1 double dot plus k1 plus k2 into x1 minus k2 x2 equal to 0. This equation I got from the FBD of mass 1, yes. Now from FBD of mass 2 I got m2 x2 double dot minus k2 x1 plus k2 plus k3 x2 equal to 0. Check. Okay. Now see, since it is having 2 degree of freedom system na, means it will have 2 natural frequency. Okay, 2 degree of freedom simply means 2 natural frequency. Now how will calculate those 2 natural frequency, that I am going to discuss. Suppose first natural frequency in radian per second I am representing as omega 1. Second natural frequency I am representing as omega 2. Omega 1, omega 2 means if you are getting 2 natural frequency, definitely one value will be lesser and second value will be larger. Like suppose 2 natural frequency are coming 10 and 20 radian per second. So lesser value, that is 10, is omega 1, that is first natural frequency. Larger value, that is 20, is second natural frequency or larger natural frequency. So right now, out of two natural frequencies, suppose smaller value is omega 1 and larger value is omega 2. Okay. So how will calculate omega 1 and omega 2? Okay. So see, actually now, when vibration will occur in 2 degree of freedom system, now how vibration will occur, now that I will, right now you will not able to understand completely. But after entire 1 to 1.5 hour discussion, now you will easily understand how vibration will occur in 2 degree of freedom system. Actually, now in 2 degree of freedom system, vibration depends upon the initial displacement, which we are providing in both the masses. Like see, because here two masses are there, na. Suppose I am displacing this mass in this direction by 1 centimeter initially and displacing this mass in this direction by 1 centimeter, then releasing this, it will vibrate. If I will displace this mass in this direction by 1 centimeter, this mass also in this direction by 1 centimeter, then I will release, it will vibrate. If I will disturb this mass in this direction by 1 centimeter, this mass in this direction by 2 centimeter, then release, it will vibrate. But form of vibration of all vibration will be different. Okay. But it is 100% sure whatever vibration will occur now, since this system is having 2 degree of freedom, means we'll get 2 natural frequency of this system. Suppose first natural frequency is omega 1, second natural frequency is omega 2. So whatever vibration will occur now, either system will vibrate only with frequency omega 1. When I am saying only with frequency omega 1 now, means here whatever equation of x1 and x2 you will get now, in that equation only one simple harmonic term will come. Simple harmonic means a sin omega t plus phi is simple harmonic term. But if I am writing an equation like this, a sin omega t plus phi, means frequency of that omega equation is omega. So if it is vibrating only with frequency omega 1, means whether you take the equation of x1, whether you take the equation of x2, will get one simple harmonic term whose frequency will be omega 1. Whose frequency will be omega 1. Now suppose that will depend upon the initial displacement. But how they will depend upon the initial displacement, that discussion I can only do after calculating these two values. Okay. Similarly, based on displacement, it might be possible system is vibrating only with frequency omega 2. When I am saying system is vibrating only with frequency omega 2, means the frequency of both mass 1 and 2 is omega 2. It means that in the equation of x1 and x2 only one simple harmonic term will come whose frequency will be omega 2. Means inside signs omega 2 t plus phi term will come. Okay. Based on initial displacement, it might be possible system is vibrating with the combination of omega 1 and omega 2. That all these things will depend upon initial displacement. Now combination of omega 1 and omega 2, it means in the equation of x1 two harmonic term will come, in which the frequency of one harmonic term will be omega 1 and frequency of other harmonic term will be omega 2. Similarly, in the equation of x2 again we will get two harmonic term, in which frequency of one term will be omega 1 and frequency of other term will be omega 2. Means ultimately the system will vibrate either with frequency omega 1 or with frequency omega 2 or with the combination of omega 1 and omega 2. With the combination of omega 1 and omega 2. But to write that displacement equation, that is equation of x1 and x2, that will depend upon initial displacement. First we should know what is the value of omega 1 and omega 2. Okay. Okay. First we should know what is the value of omega 1 and omega 2. So first I am discussing how to calculate omega 1 and omega 2. Now see, when I am discussing how to calculate omega 1 and omega 2 now, so for natural frequency calculation, right now I am assuming that system is vibrating only with one frequency, whether it is omega 1 or whether it is omega 2. So suppose that one frequency I am representing as omega. So means if I am assuming system is vibrating only with one frequency, suppose that frequency is omega. So in equation of x1 and x2 only one harmonic term will come whose frequency will be omega. And with this assumption we will calculate the value of omega. With this assumption we will calculate the value of omega. Automatically after calculation I will get two value of omega. Lesser value will be omega 1 and larger value will be omega 2. But to calculate this natural frequency, right now we are assuming for system is vibrating is vibrating only with frequency omega. So in the equation of x1 and x2, okay, one second. In the equation of x1 and x2, only one simple harmonic term will come, whose frequency is omega. Okay. So suppose the equation of x1 is like this. Suppose when it is vibrating only with frequency omega, suppose the amplitude of mass 1 is capital X1, because general equation of simple harmonic is like this, na? A sin omega t plus phi, where A is amplitude, omega is frequency, phi is phase angle. Okay. So suppose the amplitude is capital X1. So write in simple harmonic capital X1 sin omega t plus phi. Similarly, equation of x2, assume the amplitude of mass 2 is capital X2, it will be like this, capital X2 sin omega t plus phi. Okay. And with this assumption, we will calculate omega. Automatically, I will get two value of omega. One will be lesser value will be omega 1, larger value will be omega 2. So this is the assumption. If you want, you can write this like this also, cos omega t plus phi, cos omega 2 plus phi. If you want to write sin omega t only, you can write, you will get same answer. But this is the general form, na? So I am writing like this. Okay. Yes. Now I will put this in equation 1 and 2. But in equation 1 and 2, you can see x1 is coming, x2 is coming, whose equation now we had assumed. But here x1 double dot and x2 double dot term is also coming. So I am calculating the value of x1 double dot and x2 double dot term also. Okay. But now this process you can remember in your mind, because it will take time na, in writing in the board. So this you can keep in your mind also. How? I will explain, don't worry. It will calculate x1 double dot. x1 double dot means I will differentiate this equation with respect to time 2 times. Now, if we differentiate this equation with respect to time 1 time, it will be differentiation of sin is cos. Okay. It will be cos omega t plus phi. Okay. But when I am doing differentiation, I will bring the coefficient of time, that is omega, outside. So can I say it will be capital x1 omega? Yes. But again, I have to do differentiation. Now, differentiation of cos is minus sin. So, it will become minus sin omega t plus phi. Okay. Now, the coefficient of time is omega. So, again, I will multiply outside with omega. So, it will become omega square. So, x1 double dot will be minus capital x1 omega square sin omega t plus phi. So, now, I am simply referring this term as sin. So, here also sin term is coming. Here also sin term is coming. Here also sin term is coming. Only difference. Here, if amplitude is capital X1, in X1 double dot, amplitude is minus capital X1 omega square. Not amplitude, this coefficient is, which is coming with sin term. Okay. And this you can do in your mind also. Na? If it is capital X1 sin, if you differentiate 1 time, it will be X1 omega. Again, if you differentiate, differentiation of cos is minus sin, so it will be minus capital X1 omega square sin term. Similarly, if you calculate X2 double dot, can I say it will be minus capital X2 omega square sin term? It will be sin omega t plus phi. Now I will put this expression, that is equation of x1, x2, x1 double dot, x2 double dot in equation 1 and 2. So we will put in equation 1, equation 1 will become, okay. Now I am directly putting, see, you will put in equation 1 na, x1 double dot is minus capital x1 omega square sin term. x1 is capital x1 sin term. x2 is capital x2 sin term. So can I say after putting in each term sin omega t plus phi will come, and you can take sin omega t plus phi common, and common part will come this side, it will become 0. So we'll put these values in equation 1. Can I say equation 1 will become like this? It was m1 x1 double dot. So m1, now x1 double dot is minus capital x1 omega square sin term, but I am not writing sin term because na, just for understanding I am writing here. Sin term will come common, it will go other side, it will become 0. Like, we'll put here, it is plus k1 plus k2 into x1, and x1 is capital x1 sin term. Then, minus k2 x2, x2 is capital x2 sin term, equal to 0. Now, this sin term will come this side, it will become 0. So, what I am trying to explain now, because you will calculate natural frequency now, actually here process is little bit lengthy. So, you need to save your time. How you can save your time? After writing this now, you need not to write these things in board. You can directly write this. Even you need not to write this. Only remember you write for natural frequency calculation, we will replace x1 by capital X1 sin term, x2 by capital X2 sine term, and x1 double dot will become minus capital X1 omega square sine term, and x2 double dot will become minus capital X2 omega square sine term. If you want, you can write this, but you can do this process in your mind. Okay. Now, when you will put in each term, sine term will come, it will get common, it will come this side, will become 0. So, even you need not to write sine term. So, it will become m1 x1 double dot. x1 double dot is minus capital X1 omega square sine term. Sine term is coming common, do in your mind, it will become this side, it will become 0. Plus k1 plus k2 x1. x1 is capital X1 sine term is coming common. Minus k2 x2. x2 is capital X2 sine term is coming common. So, finally, this equation will be like this. Now, after finding this equation, from this equation, either find capital X1 by X2 or find capital X2 by X1. It is your will. So, right now I am finding capital X2 by X1. So, what will happen now? It will be minus m1 omega square. Here also capital X1 is coming. So, plus I can take this common k1 plus k2 into capital X1. Minus k2 x2, it will come this side, it will become plus k2 capital X2. Yes. Now, from this I can calculate capital X2 by X1. It will be X2 by X1. So, K2 will come below side. So, it will be minus M1 omega square plus K1 plus K2 divided by K2. Suppose this is equation 3. Okay. Now, repeat same process in equation 2 and again calculate X2 by X1. If you will calculate capital X2 by X1, from equation 2 also calculate capital X2 by X1. It is very easy. It is just a process. Now it is M2 X2 double dot. Now I am doing directly. Now X2 double dot is minus capital X2 omega square sine term. Sine term will come common. It will go other side. It will become 0. Minus K2 X1. So it is minus K2. X1 is capital X1 sine term. Plus K2 plus K3. X2 is capital X2 sine term. Sine term will go other side. It will become 0. Now it is minus M2 omega square X2. Here also X2 is coming. So take X2 common. So plus K2 plus K3 into X2. Now here X1 is coming. Now this is minus K2 X1. Shift this side, so it will become plus K2 X1. Do calculation correctly. Now from this try to find capital X2 by X1. It will be, this X1 will come below side. This term will come this side. It will become K2. It is M2 now. Upon minus M2 omega square plus K2 plus K3. Suppose this is equation. Okay. Very simple. I am repeating these steps. From FBD of mass 1, I got this equation. From FBD of mass 2, I got this equation. For natural frequency calculation, I am assuming it is vibrating with only one frequency. Suppose that is omega. So X1 will be this. You can do in your mind. Capital X1 sine term. X2 is capital X2 sine term. Sine term is sine omega t plus phi. Then X1 double dot will be minus capital X1 omega square sine term. X2 double dot will be minus capital X2 omega square sine term. Now put this in equation 1 and 2. Sine term will come common. It will go other side. It will become 0. And from both the equation, find capital X2 by X1. So this capital X2 by X1 I got from equation 1, which I am referring as equation 3. This expression I got by putting this value of X1, X2, X1 double dot, X2 double dot in equation 2. And I got this equation, which is equation 4. Now see, both equation 3 and 4 are representing capital X2 by X1. So definitely I can equate equation 3 and 4. Okay. This is the final equation. Capital X2 by X1 equal to, from equation 3 it is coming minus M1 omega square plus K1 plus K2 upon K2, that is equal to equation 4 is K2 upon minus M2 omega square plus K2 plus K3. Yes. From this, I will calculate frequency equation. Yes. Means what will happen now? Mathematically, what will do? Just multiply both of these two. You will get a polynomial. But in polynomial, na omega to the power 4 will come. So for frequency calculation, if you want to reduce your calculation, what will you assume now? Here put omega square by lambda. Replace omega square by lambda. Now, if you replace omega square by lambda, now you will get double order polynomial. Double order polynomial means you will get equation like this: a lambda square plus b lambda plus c equal to 0. And if I will get double order polynomial, means definitely I will get two value of lambda. Now suppose the lesser value of lambda I am referring as lambda 1. The larger value of lambda I am referring as lambda 2. Just for understanding, suppose after replacing omega square by lambda, I got two value of lambda. One value of lambda is 4. Another value of lambda is 9. Just for understanding. So lesser value is lambda 1 means omega 1 square. Because lesser value is lesser natural frequency square, and lesser natural frequency I am referring as omega 1. Larger value of lambda is lambda 2 means it is omega 2 square. So ultimately square root of this will be omega 1. So omega 1 will be root 4, that is 2 radian per second. And square root of this will be omega 2. So omega 2 is root 9, that is 3 radian per second. So ultimately after finding two value of lambda, I will get two value of natural frequency, which was our objective is to calculate. Lesser will be lesser natural frequency or first natural frequency. Larger value will be larger natural frequency or second natural frequency. So like this. What are the step now? What are the step? I will discuss with one example also. From a body of mass 1, first calculate, find this equation. From a body of mass, replace this equation. Then do this replacement. Calculate x2 by x1 from both equation, equate them, and then replace omega square by lambda. You will get double order polynomial. So you will get two value of lambda. Lesser value is lambda 1, that is omega 1 square. Larger value is lambda 2, that is lambda 1 is not frequency, it is the frequency square. Then square root of this will be frequency. But you can say, sir, if omega 1 square is 4, omega 1 will be plus minus root 4 na? Mathematically it is correct. But frequency will always be positive. So negative is not practical value. So ultimately, if you will take practical value, you will get two value of omega. Okay. Now it will be better if I will discuss this with one example. Okay. This example I will take as reference na, to explain all the concept. Like for natural frequency calculation also, this example I will take for mode shape, explaining mode shape also. See. So what I am assuming now, suppose just for understanding, let it will be given in the question. This is my assumption. K1 is equal to K2 is equal to K3 is equal to K. Okay. Suppose the question is stiffness of all spring are given same and it is K. M1 is equal to M2 is equal to M. Okay. Yes. Now I will take this assumption. This equation will become the equation of x2 by x1. It will become minus M1, but M1 is M right now, omega square plus K1 plus K2. And K1 is K, K2 is also K, so it will become 2K upon K2 which is K, that is equal to K2 which is K upon minus M2 which is M, omega square plus K2 plus K3, and K2, K3 both are K, so it will be 2K. Okay, that will be, but suppose if this information is given now, then why I will derive this equation in terms of M1 and M2? I will directly take this as K, 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 M, M. So automatically you will get the equation in terms of M and K. Okay, but this was journal form. Okay, now solving this equation is lengthy. It is mathematically very difficult. That's why I am simplifying these things. Okay. Now from this equation, for this combination, I am calculating two natural frequency now. So what we'll do? Now replace omega square by lambda. So it will become minus m lambda plus 2K. Now I am doing direct calculation. Multiply this part this side. So it will become into minus m omega square, which is again lambda plus 2K. That will be equal to, multiply this two term, K square. Now just expand this. So it will be minus m lambda into minus plus m square lambda square. Do calculation carefully na. Now minus plus minus 2km lambda. Now this, multiply this with this two term. So plus minus minus, it will be 2km lambda. Now plus 2 to the 4k square is equal to k square. So it is m square lambda square minus 2km. So it will be minus 4km lambda. K square will come this side. So 4k square minus k square, it will be plus 3k square equal to 0. Very simple. Now it is double order polynomial, so you can calculate two value of lambda. So okay, now if equation is like this, ax square plus bx plus c equal to 0, then equation to find two root of the equation is x is equal to minus b plus minus root over b square minus 4ac upon 2. Use same formula. So how will calculate lambda? It will be minus b. B is the coefficient of lambda, which is minus 4km. So it is minus of minus 4km plus minus root over b square. So b is minus 4 km. So it is the square of minus 4 km minus 4 ac. A is the coefficient of lambda square, which is m square. So 4m square. C is this part, which is 3k square upon twice of a. A is again m square. Okay. Now you can see now. Always now automatically from above now km part will come common. How? Here km is coming. Now here you can see it is km whole square. Okay. Here also k square m square means inside root km whole square is coming. So from these two terms I can take km whole square common, and if we bring outside root it will become km. So here also outside root km is coming, here also km is coming. So can I take this km common? Below side already 2m square is coming. Now this is the calculation. So after taking km common, here minus minus plus 4 will remain, plus minus. It will be root over na. Minus square is plus and 4 4 is 16. Apart from this km whole square is coming, which I had taken common. That's why it has come outside root, it has become km. Now this minus 4 3 is 12 km whole square, which I had taken common. Yes. If you want, yes. It will be 1 m will get cancelled, so it is k by 2m. Now 4 plus minus square root of 16 minus 12 is root 4. Root 4 is 2. Okay. So ultimately I will get two value of lambda. First calculate the value of lambda by taking minus sign, because that will be lesser value. So it will be 4 minus 2, 2. 2 divided by 2 is 1. So it is coming k by m. Similarly, calculate the value of lambda by taking larger value. Means by taking plus sign. So it will be 4 plus 2, 6. 6 divided by 2 is 3. So it is 3k by m. Okay. So lesser value of lambda is nothing but omega 1 square, because lesser natural frequency is omega 1. Okay. Or if you want to denote with as omega n1, it is your notation. Similarly, larger value of lambda is omega 2 square. So can I say here omega 1 is root k by m in radian per second, na? Okay. And omega 2 is root 3k by m. So like this, you can calculate natural frequency. Yes. If exam asking what is first or larger natural frequency, this is the answer. For this combination, what is second or, sorry, exam asking what is first or smaller natural frequency, that is the answer. What is second or larger natural frequency, this is the answer. So like this, you can do calculation. So it is the natural frequency calculation. I think you will be able to solve the problem of calculation of natural frequency. Okay. Like I am discussing with one more question, it will be better clear. Okay. For the spring mass system shown in figure, the mass m is 10 kg. Both mass is m, na, which is 10 kg. K, spring stiffness of both spring is k. And the value of k is 1500 Newton per meter. Then exam asking the lowest natural frequency, that is first natural frequency radian per second. Exam asking highest natural frequency in radian per second. So we have to calculate both frequency. Okay. So I am drawing this diagram here. First derive the governing equation. After that, the steps are very easy. Okay. Okay. If you want, you can directly put the value also. It is your will. This m is 10 kg. It is also 10 kg. Or first derive in terms of m and k. Then you can put the value. It is your will. Stiffness of this spring is 1500 Newton per meter. I am directly putting the value. This is also 1500 Newton per meter. Now suppose this is mass 1. This is mass 2. This is spring 1, spring 2. Only 2 spring are there, na? Yes. Now, suppose the displacement of mass 1 from mean position is x1 and displacement of mass 2 from mean position is x2, right? I am taking both x1, x2 downward. Okay. Now what we'll do, we'll draw the FBD of mass 1 and FBD of mass 2, na? So with mass 1, this spring is attached, which I am cutting from this location. With mass 2, this spring 2 is attached, which I am cutting from this location. So, sorry, with mass 1. Now with mass 2, only spring 2 is attached, which I am cutting from this location. So draw the FBD. This is mass 1, whose mass is m equal to 10 kg. Okay. with this spring 1 is attached, which I am cutting from this location, and stiffness of spring 1 is K. Okay, value is written here. This is spring 2, which I am cutting from this location. Now here I am drawing the ABD of mass 2, whose mass is 10 kg. Okay, with this only spring 2 is attached, which I am cutting from this location. Now first I will apply restoring force. Okay. And here again restoration will only occur due to stiffness. So in restoring force we will only consider stiffness. Is restoring force due to stiffness of the spring. The formula to calculate that restoring force is stiffness of the spring into displacement of spring from mean position. But here restoration will not occur due to gravity. Again reason is simple. Here weight is coming in the direction of vibration, but weight are supported by the spring. So due to weight there will be static deflection in the spring which will cancel each other effect. Same concept was coming in single degree of freedom system also. So here restoration will not occur due to gravity. That's why during vibration equation calculation, neither will consider weight nor will consider static deflection due to weight of the system, because they will cancel each other effect. So only consider the displacement from mean position. Okay. Now see, spring force of this spring. So this is between mass 1 and fixed. Displacement mass 1 is x1, it is fixed. So can I say, since the displacement of this spring will also be equal to x1, and as per this direction spring 1 will elongate. So can I say right now, as per this direction displacement of spring 1 is x1, and by this amount spring 1 is elongating. Okay. So spring force of spring 1 will be kx1 or 1500 x1. Use SI unit, 1500 x1. But its nature is important. Its nature is tensile. So this is the ABD of spring 1, which I cutted from this location. So first draw the nature. Its nature is tensile as per this information. So at this point draw such a row which will try to elongate this portion. For that I need to draw a row like this. Now what is the force? So stiffness is 1500 and displacement is x1. Completed. Okay. Now here we require the displacement of spring 2. So see, spring 2 is between x1 and x2. So either we have to assume x1 greater than, because if x1 is greater than x2, displacement of this spring will be x1 minus x2. By this amount this spring will contract. If x2 is more, displacement of this spring will be x2 minus x1. By this amount spring will elongate. Now it is your will, whatever assumption you want to take, you can take and draw the arrow as per that assumption. But whatever final equation will come, it is valid for all combination of x. Like right now I am assuming x2 is greater than x1. It is your will. But whatever final equation will come, that is valid for all combination of x. Now if we are assuming x2 greater than x1, means x2 is dominating. So right now this spring is between x2 and x1, and since x2 is more, can I say displacement of this spring will be x2 minus x1? And by this amount x2 spring, this spring will elongate, because as per x2 it will try to elongate this spring, and since it is dominating, so by this amount it will elongate. Elongate means spring force of this spring is tensile. Now this is the ABD of spring 2 which I cutted from this location. Now spring 2 is elongating means nature is tensile. So first draw the nature. So at this point draw such arrow which will try to elongate this portion. For that I need to draw arrow like this. This is the arrow. Now value. The stiffness of this spring is 1500. Displacement is x2 minus x1. So it will be 1500 into x2 minus x1. Now this is also ABD of spring 2 which I cutted from this location. And nature of this spring force is tensile. So again draw such arrow which will try to elongate this portion. For that I need to draw arrow like this. Now value is 1500 x2 minus x1. Okay. Completed. No other spring are coming. Now inertia force. The inertia force in the ABD of mass 1. So mass of mass 1 is m or 10 kg. Now its displacement from mean position is x1. So can I say acceleration will be x1 double dot, and since we are calculating by differentiation, its direction will be same as x1. So can I say inertia force of mass 1 will be its mass, which is 10 kg, into acceleration which is x1 double dot, and it will be opposite to x1 double dot. Right now x1 double dot is downward, so it will be upward. Similarly, inertia force of mass 2 which will come in the body of mass 2. So mass of mass 2 is 10 kg. Its displacement is x2, so acceleration will be x2 double dot, and direction of x2 double dot is same as x2. So can I say inertia force of this mass will be 10, which is mass, into x2 double dot, and its direction is opposite to x2 double dot. Right now x2 double dot is downward, so it will be upward. Now what we'll do? To derive first governing equation from in the ABD of mass 1, I'm going to take summation of force in y because all forces are coming in vertical direction and equate with 0. Now while using this equation, suppose I am adding upward force and subtracting downward. So it is upward which I am adding plus 10 x1 double dot. This 1500 x1, it is also upward which I am adding. So plus 1500 x1. This force 1500 x2 minus x1 is downward which I am subtracting. So minus 1500 in bracket x2 minus x1. It is equal to 0. Now simplify this. Now here you can take from each term you can take 10 common. Now it is your will. If you want to take 10 common, you can take. Common part will come, this side will become 0. If you don't want to take 10 common, don't take. But final answer will be same. Right, I am taking 10 common. So it will become x1 double dot. Here only 150 will remain. So 150 x1 minus, it will be, here also 150 will remain. Now expanding this. So it will be 150 x2 minus plus 150 x1. 10 I have taken common. And common part will come this side, it will become 0. Now write x1 double dot term first, then x2 double dot term, no x2 double dot is coming to me. Then x1 term. So it is 150 x1 plus 150 x1. So it will be 300 x1. Then x2 term, it is minus 150 x2 equal to 0. This is equation 1. Okay. Similarly, in FBD of mass m2, will take summation of force in y direction and equate with 0. Again, while using this, I am adding upward force and subtracting downward. So this 10 x2 double dot is upward, which I am adding. So it is plus 10 x2 double dot. This force 1500 x2 minus x1 is also upward, which I am adding. So plus 1500 in bracket x2 minus x1. No other force is coming, so equate with 0. Now just expand. Again, I am taking 10 common. Common part will come that side, it will become 0. So it will x2 double dot will remain. Here 150 remain. Now expand this. Plus 150 into x2. So plus 150 x2 plus 150 plus minus 150 x1 equal to 0. Now first write x1 double dot term, but no x1 double dot is coming. Then x2 double dot. Then x1 term minus 150 x1. It is your will. If you want to write in the sequence, plus 150 x2 double. See, if examiner asking governing equation in matrix form, it will be better if you write in the sequence. Yes, suppose this is equation 2. Now for natural frequency calculation process is very simple. Assume at one time system is vibrating only with one frequency, that is omega. So what I will do now, I am not writing in the board. I will replace x1 by capital X1 sine term, that is sine omega t plus phi. x2 by capital X2 sine term. If you want, you can write in the board. Then we'll replace x1 double dot by minus capital X1 omega square sine term and x2 double dot by minus capital X2 omega square sine term. Okay, and find the equation which we'll get. So what I am doing? I am doing this replacement in equation 1. So equation 1 will become, okay. Since I am explaining now, I am writing in the board also, but you need not to write. Put x1 equal to capital X1 sine term. Okay. Just since I am explaining, that's why I am writing, but you need not to. This you can do in your mind. x2 by capital X2 sine term. Then x1 double dot by minus capital X1 omega square sine term. And x2 double dot by minus capital X2 omega square sine term. And when we'll do this replacement, in each term sine term will come, and that will come common, it will come this side, it will become 0. So even you need not to write sine term here. So ultimately this equation 1 will become, it is x1 double dot, and I am replacing x1 double dot by minus capital X1 omega square sine term. That's it, sine term will come common, it will go other side, it will become 0. Then see equation 1 na, plus 300 x1. So plus 300 x1 by capital X1 sine term. This is equation. Minus 150 x2. So minus 150 x2 is capital X2 sine term, equate with 0. Now from this calculate capital X2 by x1. Na? So it will be minus omega square capital X1 I am taking into moment. It is coming here also, it is coming here also. Plus 300. Now this is minus 150 x capital X2. It will come this side, it will become plus 150 capital X2. Now from this find capital X2 by x1. It is coming, x1 will come this side, 150 will come this side. So it is coming minus omega square plus 300 divided by 150. Suppose this is equation 3. Similarly, do this replacement in equation 2. It will become, equation 2 is this, x2 double dot. So it is minus capital X2 omega square sine term minus 150 x1. So it is minus 150 capital X1 sine term plus 150 x2. So it is plus 150 capital X2 sine term, that is equal to 0. Sine term will come common, it will go other side, it will become 0. Now from this also again find capital X2 by X1. So here capital X2 is coming, here also capital X2 is coming. So you can take common. So it will be minus omega square plus 150 into capital X2. Now this is remaining. It is minus 150 x1. It will come this side. It will become plus 150. From this also find capital X2 by X1. It will be X2 is by X1. So it will be 150 divided by minus omega square plus 150. This is equation 4. Now both equation 3 and 4 are representing X2 by X1. So I can equate them. Equate equation 3 and 4. It will become capital X2 by X1 equal to, as per equation 3 it is minus omega square plus 300 divided by 150 equal to 150 upon minus omega square plus 150. Okay. Now what we'll do? Put or replace omega square by lambda. It will become minus lambda plus 300. Now multiply, shifting this side. So it will become into minus lambda, replace omega square by lambda plus 150. That will be equal to 150 into 150. It will be 150 square. Okay. Now calculation is your part, na? So it is minus lambda into minus lambda plus lambda square. Yes, good. Now minus lambda minus plus minus 150 lambda plus minus minus 300 lambda. Now plus into plus is plus 300 into 150. It is coming 45000. Now this 150 square will come this side. It will become minus 150 square. That is 22500. That is equal to 0. Here I am writing. So finally this equation is coming lambda square minus 150 lambda minus 300. That is minus 450 lambda. Now plus 45000 minus 22500. It is coming plus 22500 equal to 0. It is double border polynomial. So from this I can calculate 2 value of lambda means 2 value of omega square. How use this formula? Lambda will be equal to minus b. B is the coefficient of lambda, which is minus 450. So it is minus of minus 450 plus minus root over b square means minus 450 square minus 4 AC. A is the coefficient of lambda square, which is 1, and C is this constant part, which is 22500 divided by twice of A, that is twice of 1. So it is coming minus minus plus 450 plus minus. Now this part root over square of minus is plus, so plus 450 square minus 4 into 22500. It is coming 335.41. Check the calculation, na? Calculation is your part. Yes, 335.41. Yes, divided by 2. Now by taking lesser value, I will get lesser value of lambda, which is coming 450 minus 335.41 divided by 2. It is coming 57.295. By taking plus value, I will get larger value of lambda. It is coming 450 plus 335.41 divided by 2. It is coming 392.705. Lesser value of lambda means omega 1 square. Larger value of lambda means omega 2 square. Okay. So now I can calculate omega 1 also. Omega 1 is root over 57.295. That is 7.569 radian per second. Okay. Similarly, larger value of lambda is this. So larger omega, that is omega 2, is root over 392.705. It is coming 19.817 radian per second. So this is known as first natural frequency. This is known as second natural frequency. Some author also represents first natural frequency as the natural frequency corresponds to first degree of freedom. Some author refer the second natural frequency as natural frequency corresponds to second degree of freedom. Okay. So here first or smaller natural frequency is coming 7.569 radian per second. So this answer is 7.569. And second or highest or larger natural frequency is coming 19.817. Now actually our system will vibrate only with this frequency, that will depend upon initial displacement, or it will vibrate only with this frequency, or it will vibrate with the combination of these two frequency. Okay. But how we'll come to know whether it is vibrating only with this or combination of these two? For that, now we need to understand one more concept, that is the concept of mode shape. Okay, but before that I am hoping how to calculate two natural frequency, it is clear to everyone. Okay. 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 Now we'll understand the concept of mode shape. Okay. Okay. Now again, now to understand the concept of mode shape, first listen entire lecture regarding this discussion. At last you will able to understand the entire concept of this mode shape. Okay, but first only listen the class. See, suppose to explain mode shape I am taking this case as reference. Now for these cases na, we have calculated x2 by x1 expression na. Ultimately we got this equation, x2 by x1 is this also, it is this also. I am writing here. Right now only understand na what I am doing. Yes. Now here now we'll calculate two mode shape. I will discuss with one example, it will better clear. Say first mode shape, what is the meaning of this na? First mode shape na, for first mode shape understanding, first calculate this capital X2 by X1 corresponds to first natural frequency. First natural frequency is omega 1. So calculate capital X2 by X1 corresponds to first natural frequency, that is corresponds to omega. It is very easy. We know the equation of x2 by x1 in terms of omega, na? Whether you are using this, because both are same. So if you want to calculate this ratio for first natural frequency, simply will replace omega by omega 1. So what we'll do, suppose this is equation, do any naming, suppose this is equation 5. Okay. Okay. Actually in my actual calculation it was equation 3 and this was equation 4. So if you want to calculate x2 by x1, you can put in equation 3 also or equation 4 also. Okay, suppose I am putting here. Okay, so see x2 by x, what will do, I put omega equal to omega 1 means omega square, because here omega square is coming by omega 1 square. Do this replacement. Okay, so I will get x2 by x1 corresponds to first natural frequency. If you put here, you will get minus m1 omega 1 square plus k1 plus k2 divided by k2. Okay, whether you are putting here, you will get same answer. But this capital x2 by x1 I have calculated corresponds to first natural frequency. So what I will do now, because this I will not write entire sentence again. So here above side I will use this word 1. So this yellow one is representing just, it is the ratio of capital x2 by x1 corresponds to first natural frequency, means it is the ratio when it is vibrating with first natural frequency. Okay. Now suppose, just for understanding, if capital x2 by capital x1 corresponds to first natural frequency. Okay. Just one second. Suppose it is coming 2. Just for understanding, I am saying, suppose it is coming 2. Okay. So what is first mode shape? Now I write first mode shape like this in vector form. First mode shape. What is the significance of this? That we'll discuss later. Only understand how I'm writing this. Okay. See, first mode shape we'll write like this. See. Okay. This thing you will study in also in matrix also when you are studying eigenvector. Same thing we are doing here. See what we'll do now. Can I say if system is vibrating only with frequency omega 1? Because this way I calculated corresponds to first natural frequency. In that case, can I say if x1 is 1, x2 will be 2? If x1 is 2, x2 will be 4 as per this information. If x1 is minus 1, x2 will be minus 2, yes or no? Means it is representing the ratio of displacement of 2 and 1. Okay. Now to write this in vector form now, what we do, assume x1 is 1, write in any one form. If x1 is 1, x2 will be 2. But it is, I'm not saying x1 is always 1. Ultimately, this is first mode shape is representing x2 by x1. If you are representing this by this or this by this. So I have calculated x2 by x1. So go this by this. Like see, if you want, you can write like this also. If it is minus 1, it is minus 2. If examiner asking first mode shape, this is also correct, this is also correct. In examiner will give only any one option. Here if it is 2 written, it will be 4. Here if it is 0.5 is written, it will be 1. Here if 0.5 is written, only you have to check the ratio x2 by x1 should come 2. Okay. But when I am writing by myself now, I will write like this. Okay. I am assuming this is 1. So what will be this? But it is not representing x1 is 1, x2 is 2. It is representing x2 by x1 is 2 or x1 by x2 is 1 by 2. x2 by x1 is 2 or x1 by x2 is 1 by 2. All are representing same. Okay. Sometime now examiner will represent like this also. 1, 2, transpose. Transpose means instead of writing vertically, we can write horizontally. Means both are same, na? Yes. Like suppose if you want to calculate second mode shape. Second mode shape. It means we'll calculate x2 by x1 corresponds to second natural frequency. So what we'll do? We'll put omega by omega 2 means we'll replace omega square by omega 2 square. So we'll get x2 by x1. Suppose I am putting here. It is your rule. You can put here also. You have put here also. So it will be minus m1 omega 2 square plus k1 plus k2 upon k2. Okay. But this x2 by x1 I am getting corresponds to second natural frequency. So I will use this suffix 2. Okay. Yes. Okay. Now suppose after calculation this x2 by x1 corresponds to second natural frequency. Suppose it is coming minus 1 just for understanding or say minus 0.5. So how you can write second mode shape? Assume x1 is 1. If it is 1, x2 will be 1 into minus 0.5, that is minus 0.5. You can also write like this. Assume x2 is 1. So if x2 is 1, x1 will be 1 divided by minus 0.5, that is minus 2. All are correct. Only you need to see the ratio of x2 by x1 should be minus 0.5. It is not saying x1 is 1, x2 is 0.5. Actually, it is saying x2 by x1 is minus 0.5 or x1 by x2 is 1 upon minus 0.5. So this is second mode shape. Okay. But what is the significance of this? What it is actually explaining? So see. For that I am taking a practical case. Practical case means when I am discussing natural frequency calculation, I have taken one case in which we have calculated frequency when K1, K2, K3 was K, M1, M2 was M. Or for this case, I got two frequency like this. One was lesser was first natural frequency was root K by M, other was root 3K by M. So I am taking this example now. So see, again K here K1 is equal to K2 is equal to K, M1 is equal to M2 is equal to A. Okay, for this case we already derived na, this x2 by x1 equation was coming like this na, minus m omega square, you can check, plus 2k upon k, or it was like this, k upon minus m omega square plus 2k, you can check. Okay, and from this we have calculated first natural frequency omega 1, it was coming root k by m, and second natural frequency omega 2 was coming root 3k by m. Okay, now I am calculating first and second mode shape. Suppose I am referring this equation as equation 1a. So first I am calculating first mode shape. Okay, for that now in this equation put omega equal to omega 1, which is root k by m, means directly you can replace omega square by omega 1 square, which is k by m. Okay, okay, after putting I will get capital x2 by x1 corresponds to first natural frequency. I will get capital x2 by x1 by corresponds to first natural frequency. It will be minus m omega square is k by m plus 2k upon k. It will be minus k plus 2k, that is k divided by k is 1. Even if you put here now you will get same answer. Omega square is k by m will get answer, so it will be minus k plus 2k, that is k divided by k is 1. So if I will write miss first mode shape, can I say? Then I will discuss its significance. But first mode shape is, assume x1 is 1, x2 is 1. But instead of this, you can write like this also, minus 1, minus 1, minus 2, minus 2, 2. Ultimately, x2 by x1 should be 1. Okay. But when I am writing by myself now, I will write in this form. Now I will explain its significance. But before that, I am calculating second mode shape also. Second mode shape means in the equation of x2 by x1 put omega by omega 2, which is root 3k by m, means replace omega square by omega 2 square, which is 3k by m. So you'll get x2 by x1 corresponds to second natural frequency. It will be minus m omega square, which is 3k by m plus 2k upon k. It is coming minus 3k plus 2k minus k divided by k minus 1. Means here the second mode shape means if x1 is 1, x2 is minus 1. Or you can also write like this. If you assume x2 is 1, x1 will be 1 upon minus 1, that is minus 1. All are correct. But when I am writing by myself, I will write like this. Yes. Now what is the meaning? See, meaning is, I was telling now, the vibration will depend upon the initial displacement. So see, the initial displacement which I am providing in both the mass, if it is maintaining this mode shape, in that case system will vibrate only with frequency omega 1. Means in the equation of x1 and x2 only one simple harmonic term will come whose frequency will be omega 1. If initial displacement which I am provided in both the masses is maintaining this ratio, means it will vibrate with only frequency omega 2, that is root 3k by m. Means in equation of x1 and x2 only one simple harmonic term will come whose frequency will be omega 2. But initial displacement which I am providing in both the masses is random. It is neither maintaining this nor maintaining this. In that case system will vibrate with the combination of omega 1 and omega 2. Means in equation of x1 and x2 ultimately two simple harmonic term will come in which the frequency of one term is omega 1, frequency of other term is omega 2. What I am saying, okay, as per this example I am explaining. This is mass m1 na? What I am trying? See, if initial displacement which I have provided is maintaining this ratio means that initial displacement which I am providing in both the masses are same. What I had done, suppose I had disturbed this mass from mean position by 1 centimeter in this direction, and I am disturbing this mass from mean position also in this direction by 1 centimeter. Means I am maintaining this ratio. So whatever vibration will occur now, the system will vibrate only with frequency omega 1 because it is maintaining this. And always the displacement ratio bit will always be equal to 1. Means what will happen now? It will vibrate only with frequency omega 1 and it will vibrate like this. Displacement of both masses will be same. If I will draw na at any place displacement curve na, it will be like this. See, this is fixed point. Okay, so their displacement is 0. Now see, you can take any value. Suppose x1 is plus 1. Okay. It is 0, so it is going 0 to 1. Now here it is 0. Now draw x2. See, if x1 is 1, x2 is also plus 1. Oh, sorry. Same value, na? Plus 1. So this, at an instant, this is the displacement diagram. Means in this example, na, when vibration will occur, na, this spring will neither elongate nor contract. It will move simultaneously because both masses are going in same direction by same amount simultaneously. This is the displacement equation. Curve. Okay. If it is vibrating as per this information, means corresponds to first mode shape. But what will happen? I am providing initial displacement as per this. So it will vibrate with frequency omega 2 and it will always maintain this relation. This relation means the x1, x2 will be same but always opposite to each other. Okay. Means what I am trying to say. Suppose initial displacement which I have provided, suppose this mass I had displaced in this direction by 1 centimeter. This mass I should displace in opposite direction by 1, na? Because yes, like this. If you are displaced this by 2, then this direction by minus 2. So I am maintaining this ratio. After that, if I will release the mass now, it will vibrate according to this mode shape with frequency omega 2. Means always both the masses will be opposite to each other. It will vibrate like this. Like this. If I will draw the displacement curve now, here it is fixed 0. Suppose displacement this is plus 1. You can take any assumption. It is 0. Displacement of this is minus 1. Yes. Okay. Now suppose like this, if you are drawing the displacement curve now, at any point in the middle, if displacement is 0 na, that point is known as node. Sometime 1 mark question can come. Okay. So that's it. And initial displacement which I am providing is neither maintaining first mode shape nor maintaining second. Means suppose I had disturbed this mass in this direction by 1 and this mass by this direction by 2. So it is maintaining neither first mode shape nor second mode shape. So it will vibrate randomly, in which vibration equation 2 harmonic term will come, in which frequency of one term will be omega 1, frequency of the other term will be omega 2. Okay, so some random vibration will occur. That will depend upon the initial displacement. I will also explain how you can write the equations if initial displacement is given. Okay. So this is the concept of first mode shape. Now this is the last topic. Now I will discuss how we can write the equation of x1 and x2. Just 1 second. How we can write the equation of x1 and x2. See, for that examiner will provide initial displacement. Now, if it is maintaining first mode shape, definitely in the equation of x1 and x2 only one frequency will come, that will be omega 1. If it is maintaining second mode shape, in the equation of x1 and x2 only one frequency will come, that will be omega 2. But if it is neither maintaining mode shape 1 nor maintaining mode shape 2, so in the equation both frequency will come. Means equation of x1 and x2 will be sum of two harmonic term, in which frequency of one term is omega 1 and frequency of other term is omega 2. So see how you can write now. Just for understanding, suppose first mode shape is like this, 1a, because right now, because for different question it will come different, na? But if you assume x1 as 1, you will get some x2. Like suppose x2 by x1 is coming 2, so it will be 1, 2. x2 by x1 is coming 0.5, it will be 1.5. x2 by x1 is coming 0.67, it will be 1.67. Okay. So you like this you can write. Similarly, suppose, okay, means x2 by x1, can I say corresponds to first natural frequency is coming A. Similarly, suppose x2 by x1 corresponds to second natural frequency, it is coming B. Just for understanding I am explaining. Okay. Means can I say second mode shape is this 1P. Okay. Now, I am assuming the vibration is occurring with the combination of frequency omega 1 and omega 2 because I am writing general equation. Because this is a special case, na? Initial displacement is maintaining only this. It is special case. The initial displacement is maintaining only this. So I am writing general equation to assume it is vibrating with frequency both omega 1 and omega 2. So how you can write the equation of x1? It is very easy. See, in x1 actually two harmonic term will come in which frequency of one term is omega 1, frequency of other term is omega 2. How I can write? So see, if it is vibrating only with frequency omega 1, that is first natural frequency, then can I say the displacement of amplitude of mass 1 is x11? Because what capital X11 is representing? It is the amplitude of mass 1 when it is vibrating only with frequency omega 1. What capital X21 is representing? It is the amplitude of mass 2 when it is vibrating with first natural frequency. Because this is capital X2 by X1 corresponds to first. Similarly, what is X12? It is the amplitude of mass 2 when it is vibrating with, it is the amplitude of mass 1 when it is vibrating with second natural frequency. Similarly, what is X22? It is the amplitude of mass 2 when it is vibrating with second natural frequency. So see, when it is vibrating with first natural frequency, so the amplitude of mass 1 is capital X1. So it will be like this, capital X11. When it is vibrating with first natural frequency, amplitude of mass 1 is capital X11. So it will be like this, capital X1 sine vibrating with first natural frequency. So here omega 1t plus 5 will come. Or you can write 5 1. For first natural frequency, I am using, okay. Similarly, when it is vibrating with second natural frequency, then the amplitude of mass 1 is capital X12. Amplitude of mass 1 is capital X12 because it is vibrating with second natural frequency. So it will be sine omega 2t plus 5 2. This is the final displacement equation of mass 1. Okay. Okay. When it is vibrating corresponds to first mode shape, now automatically X12 will come 0. This part will come 0 automatically. If it is vibrating correspond to second natural frequency, automatically this will come 0. And it is vibrating with the random order, neither maintaining first mode shape, second mode shape. So both X11 and X12 will come automatically. Okay. Similarly, what will be the equation X2? Okay. See, when it is vibrating with first natural frequency, then the amplitude of mass 2 is capital X21. Capital X2 corresponds to first. Sine omega 1t plus phi 1. Similarly, when it is vibrating with second natural frequency, the equation will be like this. Amplitude of mass 2 will be capital X22 sine omega 2t plus phi 2. Okay. Now further, if you want to simplify, now after that, first write like this. Can I replace X21 by A X11? So you can replace this X21 by A X11. Similarly, can I replace X22 by B X12? So here you can replace X22 by B X12. So if you want, you can do this replacement. Na? But this is the final displacement equation. Okay. Now if initial conditions are given, this is mathematics, you can find X11, X12, X21, X22 also. And you will get final equation. But that is very lengthy part. So generally from that calculation question will not come. But which type of question can come? See this question. What this question is saying, a 2 degree of freedom spring mass system undergoing free vibration with generalized coordinate x1 and x2 has natural frequency omega 1 equal to this. This is first. This is second. Now this is first mode shape and this is second mode shape. Now examiner is saying if the system is disturbed with certain deflection and zero initial velocity, means initial velocity as zero, then which one or more of the following statement are correct? It is MSQ, means more than one option can be correct. Now can I say, I will read the option later, but can I say if displacement is maintaining this ratio, it will vibrate only with frequency this. If it is maintaining this mode shape, it will vibrate only with this frequency. And if it is maintaining neither this nor this, it will vibrate with the combination of these two frequency. Yes or no? That is the main conclusion. Okay. Now see, option A is saying if initial condition is x10 is 6.32, x20 is minus 3.16, then system will vibrate only with second natural frequency. That is correct or not? So see, calculate x2 by x1. x2 by x1 is minus 3.16 divided by 6.32. It is coming minus 0.5. But corresponds to second mode shape, it is 3.16 divided by 1. So actually this information is not maintaining this. Because as per this x2 by x1 is 3.16. But as per this it is coming minus 0.5. So it will not vibrate with second natural frequency, only with second natural frequency. So that is incorrect. Suppose instead of this, if examiner is written first natural frequency, then also it is incorrect. Because as per this, it is x2 by x1 is coming minus 3.16, but here it is coming minus 0.5. Means it will vibrate with the combination of both. But here examiner is saying only with second, that's why it is incorrect. Now option B. If initial displacement x10 is 2, x20 is minus 6.32, so it will vibrate only with first natural frequency. Let's check. x2 is minus 6.32 divided by x1 is 2. It is coming minus 3.16. Minus 3.616 divided by 1. Yes, it is maintaining first mode shape relation. Means it will vibrate only with frequency first. Same is written here. So option B is correct. Now see, but since it is MSQ, that's why I am focusing on all the options. See, saying if it is initial x10 is 2, x20 is minus 2, it will vibrate with the combination of first and second. So see, here x2 by x1 is minus 2 divided by 2 minus 1. Now here x2 by x1 is minus 3.16. So it is not maintaining first mode shape. Here x2 by x1 is 3.16 divided by 1. It is not maintaining second. Means it is not maintaining both mode shape now. Means it will vibrate with the combination of frequency omega 1 and omega 2. Same is written here. So C is also correct. Now D. If x10 is 1, x20 is minus 6.3, it will vibrate only with first. So minus 6.32 divided by 1, it is coming minus 6.32. But it is minus 3.16 ratio. So it is not maintaining first mode shape. So D is also incorrect. So for this question, correct options are option B and C. So like this, you can solve this type of problem. Clear? Yes. So today we had discussed 2 degree of freedom vibration. First we had discussed introduction part. Then we have discussed what is the coupling, static and dynamic coupling. Then we have discussed how to calculate natural frequency. This part is very important. Then we have discussed the concept of mode shape. Then we have discussed how to write displacement equation. Okay, that's it. Ending the class, na? Okay, we'll meet tomorrow. Tomorrow we'll discuss continuous.